So today's session, I want to do two things. A very quick review of what we have done last time regarding Firebase Cloud Services. And then I want to spend most of the session on the new topic, which is the background processing using WorkManager. So let's quickly do a quick review here, and also I can answer if you have any pending questions regarding Firebase Cloud Services. So Firebase is a cloud platform from Google offering many services that can work together to provide backend services for your app, whether a mobile app or web app. And you can use these services without spending time and effort to set up and maintain your own servers. And you can just sign up and start using these services. It offers many services. In here, we concentrated on three services. The Cloud Firestore, used to store and query documents. These documents look like JSON documents, and these documents are stored inside collections. And you can go ahead and add documents, update documents, and query documents. Second service is Cloud File Storage, which allows us to simply store files and download files. And the third service is Firebase Authentication. This is used for easily implementing sign up and sign in for users, either using simple email and password authentication, or you could use third-party authentication such as Google Authentication, Facebook, Twitter, and so on. Now for Firebase Firestore, for the Firestore service, you simply have documents that you store inside collections. Example documents in our shopping list app that we've seen last time. So I have here two top-level collections, categories collection, storing categories, and for each category it has a collection of products. So in here each category has a sub-collection associated with it. And then the second top-level collection is the shopping items. So whenever the user adds a shopping item, an item to their shopping list, it will be added to this collection. Once you define your collections, you can use the API, Firestore API, to read, write, and update and delete documents. And to do so, first you create data classes that represent the documents that are managed in your Firestore. Map to Firestore here, should be Firestore, map to Firestore documents. And these are normal data classes, nothing so special about them, except that for the ID, the property that represents the document ID, you annotate it with this @document ID. And this instructs Firestore to store the document ID in this, automatically store the document ID in this property. Then you can make use of the API that comes with the Firestore to read and write documents. So for reading, you simply get a reference to the collection you want to read from by saying firebase.firestore.collection, and you specify the collection name. And then if you want to read all, you just use .get. And you wait for the results to come back, and then you convert the results from a list of documents to a list of objects using this toObjects method. If you don't want to retrieve all the documents, you can do a where condition, and you can say go to this collection and only give me the document that meet this condition. In this scenario, I only want to get the documents where the name is equal the category name. Now for adding, very simple, you go to your collection reference, you go to your particular, you get a reference to your particular collection you want to add a document to, and then you call the add method. and you give it the object you want to store, it will go ahead and create a document and auto assign an ID to it. And you can get the ID that was assigned to the new document by going to the query result.id. This will give you back the ID generated. In some scenarios, you don't want Firestore to generate an ID for you. So in this case, don't use add, because add generates the ID automatically. Use set instead. So in here I'm saying, go ahead, add this new document, but I want you to use the user email as the ID, and then you go ahead and say set user, and this will create a new document, and the ID is basically the email of the user. And as you can see here, the ID will be the user email. To update a document, you get a reference to that particular document you want to update, and then you call update and pass the name of the column you want, the name of the field you want to update, and the value. It could be, you could pass many name value pairs, or you can put these name value pairs in a map and pass the map to the update to update multiple fields at the same time. To delete, simply you get a reference to the document you want to delete and call the delete method. Finally, when you get documents from the Firestore, you could simply get them like this. So you can do where condition and get your document, and that's it. You get the results and finish the query. Or you could also subscribe to any changes that will happen in the future to this document. So whenever a new document is added to the collection, or a document is updated or deleted, the Firebase will automatically, Firestore will automatically notify your app and gives it the, in this scenario, the shopping items belonging to this user whenever the shopping items of this user gets added, updated, or deleted. So all I do, I go to the query and call this add snapshot listener, and this will notify my app of any changes that will happen to my collection. The changes that meet this condition, I will not get notified for changes, for example, of shopping items that belong to a different user. I will only get updates about the changes that happen to the shopping item of the currently logged in user, or the user having this particular ID. Then I'll go to this snapshot parameter. This will give me the updated list of items, the whole list of items. And I can simply convert them to a list of objects. And typically I'll store them in a live data, so the UI will be updated. So I may have a recycler view, for example, a fragment having a recycler view, and a fragment is observing this live data here, and whenever it changes, it refreshes the UI. So this is very powerful, highly recommended to use, and you can get further details about it by watching this very nice video explaining this in much more details. But this is the basic idea of it, and it's already used in the example app that I already provided. Finally, you can secure your data. In here, I just want to give you a glimpse. We are not getting into too much details here. This is the maximum rule we will write in this course. So in here, I'm saying to Firestore, allow only authenticated users to access any document in my collection. So we secure data by defining security rules. And these rules have two parts: match statement and allow expressions. So the match statement gives you the path in your collection that you want to secure. So in here, I want to basically match any document in my collection. If somebody tries to access any document in my collection, this rule will apply. And the rule says, allow a read and a write only if the request.auth.uid is not null, which means only allow read and write if the user is already authenticated. And I will show you shortly how authentication works in Firebase. So you can define much more sophisticated rules, but these are beyond the scope of this course. For us, this is more than enough. We're just securing our data, and we only allowing authenticated users to access any document. But you can define a more advanced rules if you wish to. Now that's it for Firestore. It's for storing JSON-like documents in collections, and you can query them, and you can even watch for updates of the collection. Second service that you need to be familiar with and you need for your project is a Firebase Cloud Storage. And this allows us to simply read and write files. It's a very simple service to use. You add this, you need to add this dependency to your Gradle, build.gradle, and then you get a reference to the cloud storage, Firebase Cloud Storage, by going to firebase.storage.reference. This will give you storage reference, and then you use this to read and write, to upload and download and list files in particular folder inside your cloud file storage. And these are the operations provided. So for uploading, you will use put bytes, and you give it an array of bytes, and it will go ahead and do the upload. Or you can give it a URI. For example, you might take a photo, pick up a photo from a gallery. That will return you a URI of that particular photo you have selected, and then you say storage ref .put file, and you give it the URI, and it will upload the file. You can also download the file, download the files using get bytes. This will return you an array of bytes, or you can download the file to a particular location on your device by using get file and passing the URL, the URI of the path, the destination path where the file will be stored. If you no longer need a file, you can go ahead and delete it, and also you can go to a folder and list all the files in that particular folder. So it's very simple API, and the example given already provides a nice example showing all of this. So this is just to give you a glimpse of how it works. You get a storage reference, and then you say, I want to go to this subfolder, and I want to upload this local file from this local file path, and I want to upload it to the online subfolder /image, and you decide the file name. So this is the destination file name. So that's basically how you upload a file to a subfolder on Cloud Firestore. To delete a particular file, you get a reference to the file by using storage ref.child, and you specify the path of the file, and then you go ahead and delete. Because everything is asynchronous, I need to do a wait to wait for the task to be completed. Okay, so that's basically the idea of Firestore. And finally, we have Firebase Authentication. This will allow us to enable users to sign up and sign into our app. We can either use a simple email and password authentication, or we can use existing online authentication services such as Google Authentication, Twitter, Facebook, GitHub, and many others. So for simple, if you just want to do a simple sign in using email and password, what you can do, you can go to your file authentication and you can create users in here. You can create them using this user interface, or you can create them programmatically, as I will show you shortly. So to create a user programmatically, or let me start with signing. Let's say there's an existing user. So what you can do, you just go to firebase.auth.signin with email and password. And then you provide the email and the password, and you wait for the authentication to take place. If everything is successful, you get an auth result, and this auth result has a user object. If it is null, means this authentication has failed. If it's successful, then you get a user object, and this user object will have the user ID and the email and other details. So this is for sign in, very simple. Sign in with email and password. Now for sign up to allow the user to sign up, what you do is you go ahead and ask firebase.auth and you say create a user, and you supply two parameters, email and password, and you wait for this to complete, and this basically will create a user. Then if you wish, you could add a bit more details to the user after the user is created. You can add a bit more details, but this is very limiting. You can only add, let's say, display name and photo ID. And then you do update profile request. So there are two steps. You create the user. Using create user with email and password, and then you can update the user with these two pieces of information, display name and photo URI, and you go ahead and update the profile. Now, unfortunately, for some reason, the online version does not show these details added. It only shows the username and password. It only shows the email. But programmatically, you can add. I have tried it; it works. You can add these pieces of details. Now, if you need more details about the user, then you have to store these details in a Firestore collection. So let me show you what I mean by this. Let me just quickly open our shopping list example. So for example, in our shopping list, and this will be the same for your project, by the way, we have a user object, and the user object, yes, has user ID, first name, last name, and email. If I only have these pieces of data to know about the user, this is enough. I can just go ahead and use Firebase Auth, and I can store all these details, the username, the email and password, the display name, and the photo URI. This is fine. This is enough if this is what you want to know about the user. But if you want to store more details, for example, I want to store the role. What is the role of the user? What is the address of the user? The address. Then this is not, the Firebase authentication is not enough. So what you do is you may store basic details in the Firebase auth, and then you store the remaining details or the full details in a user's collection. So you can see here there is a user collection here, and it has more details. It has first name, last name, role, and the address. And you can see here the password is not stored. It's very important not to store the password. That's why I put here @get exclude, and this makes sure that when I store this user object on Firestore, the password is not stored, and this is important. Okay, so let me show you the full story. So what I do here, this is the authentication repository. I go ahead and do sign up. Here is the sign up. First, I create a user in Firebase Auth using the username and password. This will return me user. If this is successful, the user will be not null. And then I'll go ahead and add the display name and photo URI to my newly created user, and more details, the full user object, if I need it, such as the address, the role, and other details, I can add them to Firestore. So I go to the user collection .document, and I use user.user ID and then set user. This is very important not to do add. Don't do something like this. Don't do add like this. This will not be very helpful. You need to use set. The reason why is basically when a new user is created using authentication, Firebase Auth, Firebase Authentication will assign a user ID to this particular user we just created. And we must use the same user ID in the Firestore. So in the Firestore, if you notice here is the Firestore. If you notice here, the user ID is exactly the same. The user ID I have here exactly the same, the user ID that was assigned by Firebase Authentication. So if you notice here, after I create the user using Firebase Auth.create user with email and password, I'll get back a user object, and I retrieve the user ID from that user object. And then when I store the full details of the user in Firestore, I make sure I use the same user ID. So these two are linked. The user object in Firebase Auth has the same user ID as the user object in Firestore. And this is important because when after sign in, for example, here is sign in, and I'll say sign in username and using username and password, this will give me a user object. This user object has, sorry, this will give me a user object. This user object already has email, has a display name, and has URI, photo URI. But it does not have a role, the address, maybe phone numbers, other details. So if I want more details, I'll go and get them from Firestore. So I'll say here, go to the users collection, go to this particular document belonging to this particular user ID, and get me that user object and convert it to a user object. Get the document and then convert it to a user object. Okay, so that's why it is important that the user document stored in Firestore must have exact same ID as the user ID generated when I sign up using Firestore.auth. So that's basically the idea. So to summarize, if you just want to have email, display name, photo URI, you can just limit your authentication to Firebase Auth, and you store all the details in your Firebase Auth authentication service. But if you need to store more details about the user beyond these simple basic properties, then you take the whole user object and store it in a Firestore collection. Okay, so I hope it's clear. If you have any question, please let me know. And then don't forget, if the user wants to sign out, you just do Firebase Auth.signout. anywhere in the app, whether it's an activity or a fragment or a repository or a view model, wherever you are in the app, you can check if the user is signed in by using firebase.auth.currentUser. If the user is signed in, this will be not null. If the user is not signed in, this will be null. You can also subscribe to changes of the authentication state. Whenever the user signed in or signed out, you can get notified and do some, maybe refresh the UI or display message or do whatever you need to do. For example, in my case here, in the app we have here, let me just go back. Okay. Okay, no problem. Let me just rerun this. All right, so here it is. Run. So I'll run it. I'll just show you that I watch for the user to be authenticated. When the authentication status change, I simply display a message and I'll go and fetch the details or fetch, sorry, the shopping items belonging to that particular user. So here it is. So whenever I already exists, okay. So I think I'm already signed in. So let me sign in. So signed in, I display this message, and plus, let's say, let me just add some items to my shopping item. Add. Okay, now if I sign out, you see this is cleared because I cannot get the list because the lists belong to a particular user. So once you sign out, you cannot get the list. Plus, I have also a security rule. A security rule here. If I go to Firestore, I have a security rule configured. Here is the rules. And this security rule says only authenticated users can read and write. So here. So even if I try to read and the user is signed out, this will be denied. The read and write will be denied. So here I'm saying match any document the user wants to access. Only allow them to read and write if the user is already authenticated. So because I signed out, the user will no longer be able to read and write from the collection. Now, if I want to add, it says login first. So let me go ahead and log in, sign in. And once I sign in, I display the message and I get back the list of shopping items belonging to this particular user that just signed in. So to be able to achieve this reactive user interface, you can simply subscribe to this event. So whenever the user signed in or signed out, you can react to this by simply going to firebase.auth.add auth state listener, and simply here you will get the current user. If it's null, it means the user is signed out. If it's not null, it means the user have signed in. So that's the summary. So Firestore, the Cloud Firestore is an online database that I can use to store and query app data in collections. And the documents that I store in this collection, they look like JSON documents. Firebase Cloud Storage is used to store and retrieve files, and Firebase Authentication is used for sign in and sign out, either using simple email and password authentication or using more sophisticated existing authentication providers such as Google Authentication Firebase, Facebook, Twitter, and GitHub. And they are very, very easy to configure. You just go through the documentation to configure them. So if I go here to authentication, you can here sign in methods. You enable any of these authentication, for example, here Facebook. And basically you need to provide some configurations. You can read a bit of documentation. You need to go to Facebook and create an app and come back here and put the app ID and the app secret. These will be given to you by Facebook. You come back and paste them in here to enable your app to use them. And this will enable you to do social media authentication or Google authentication. Okay, that's it for this. If you have any question, please let me know. And you will need all these skills. Hopefully you already practiced some of them in the lab, and you will surely practice them on your project, and you will extend the base solution that I already posted yesterday. Okay, so if there are no questions, let me just quickly introduce the next topic, which is the topic before last. So inshallah, next week we will be covering, or from next session we will be start to cover the map, Google Maps, how to use Google Maps and interact with Google Maps within our app. But for today, I want to introduce background processing using WorkManager. So WorkManager is a library, is an Android library that allows us to run deferrable background tasks. Deferrable means it does not need to run now. It can run in the future, and it can run when certain conditions are met. You can specify some constraints. You can say run this job only when the device is idle. Run this task only when the phone is plugged to the power. Run these tasks only if there is Wi-Fi. And these background tasks, such as, for example, I'm sure you have seen in WhatsApp, sometimes you will see WhatsApp doing backup of your messages. So that could be a background task. For example, in your gallery, photo gallery or app, you could configure it to synchronize whatever photos you take to post them on the cloud. So your photos are not immediately posted, but there is a background worker that will compress and post those files to Google to Google Drive. So basically, you can schedule tasks to run periodically. For example, let's say every 10 minutes, I want you to go to Firestore, get the data from Firestore, and update my local database. You could do that. You could schedule some tasks to be periodically running, and they will be running even if the app exits. So even if the app is not available, it can still run. And if the run fails, it can retry. It can automatically retry. So it's very powerful and very simple, as you will see shortly. So your app could not be active, and it can still perform some tasks. So how it works? Very simple. If you simply want to do some work in the background, first thing you need is to create a worker class. So it's a simple class that inherits from worker. And then this class, you implement one method called do work. And in here, your imagination is the limit. You can do whatever you wish to do. Compress files and upload them. Do whatever task you need to do. Back up your chat messages to an online database. Synchronize an online database with your local database. Whatever background task you wish to run. You go ahead, do it. If everything goes okay, return a result.success. If something goes wrong, return result.failure. That's it. That's basically the piece of work. The piece of work you want your worker to do, you put it inside the do work. And this do work must be inside a class that extend worker. So this is how you define the work to be done. Now, once you define the work to be done, how do you launch this work? How do you start this work in the background? So what you do is you take the work you created, the worker you have created, and then you create, either you create a one-time work request or you can create a periodic work request. One time means you do it once, وخلاص, finish. A periodic means you do it every interval, every 10 minutes or every hour or every week or every day. You can schedule it. So if you just want to run it once, so what you do is you go ahead and create an instance of one-time work request using the one-time work request builder. You pass to it the download worker. I mean the worker you want to run, and you go ahead and say build. This will create a request. This will create a request. Then what you do, you go to your work manager and you say get me an instance of this work manager and on queue this work, and that's it. So the work manager is already running on your Android device, and it will take this request and schedule it. And the work manager also has a database to store this request. So even if you make this request and switch off your phone or exit your app, this work will still be done. It will still continue working even if your app is closed. Even if you reboot your machine, your device, and you come back, this work will be executed. This is guaranteed. You see here, this is deferrable and guaranteed execution. So if you call a method, for example, using a coroutine, as we saw before, it can run, but if your app exits, that work will be stopped. But if you use a work manager and create a worker and do some work and schedule that work to be done, then it is guaranteed to be executed no matter what. So this is how you schedule it. You get an instance of the work manager and you say on queue, put this work on the queue and go ahead and execute it. Okay. Now you could launch it immediately or you could launch it periodically. It looks very similar. So what you do here, periodic work request builder, you say take this work for me and run it every minute. And this will run every minute. I think I tried this. It doesn't really run every minute. I think they have some restriction. I have to further explore this. I think minimum period is 15 minutes. Maybe because they put this restriction just to save battery life. But I have to verify this information. I think the minimum time is 15 minutes. But anyway, you specify the time. You create a periodic work request, and then you in-queue it. Then the work manager, every 15 minutes, will execute this task. Every 15 minutes, even if your app is not started, even if your app is closed, this will take place. So this is a one-time request, not repeatable. And this is periodic request, automatically repeated after 15 minutes. When you create a work request, you can also define some constraints. So here you say, I'm defining some constraints. I want for this work to take place, let's say upload worker. For this upload worker, I want two things to take place. I want two conditions. I want the phone to be charging. If the phone is not charging, then don't run this work. Wait until this condition is fulfilled. And I want the phone to be connected to the internet. Then go ahead and run this work. So let me show you this just to give you a glimpse. So let me close this guy. Here are the constraints. So I can say here, set require battery not low, require charging, require device idle. If the user is using the device or the device is doing some heavy work, don't run this task yet. Wait until these constraints become true and then go ahead and do the work. You can trigger a task after certain delay. Now for the network, so you can, let me see here, device idle. Require device idle true. Require charging true. Require internet. Here, any connection. It could be Wi-Fi, 4G, whatever it might be. Or you can say metered. This is only if it is 5G or 4G. And unmetered for the Wi-Fi. So this work, for example, if you are uploading, backing up some photos or some large multimedia, you can schedule them to run when you are connected to Wi-Fi, not to 4G, for example. And only to do that when you are not using your phone or the phone is not doing much. So you can put all these constraints. You can put all these constraints, and now when you create a request, you go and say one-time work requests. You can specify the constraints. You can specify the constraints. You can also pass some input values. You can also pass some input values to your worker. How do you pass input values to your worker? You create a data using this data builder. And data is basically a name value pair. Name equal value. It's like a map. Name equal value. And then you can pass them as parameters to your worker. So you define name value pair. This one is a constant just to avoid putting something like count value. Instead of hard coding this value, it's not a good practice. So you put this value in a constant. You put this value in a constant. And then, so if this change, for example, if you want to rename it this, it's fine. You can rename it because your app is only aware of this. So this is always a good practice to use constants rather than hard coding these values directly. So let me go back here. So here I am doing data builder dot put int. Instead of hard coding this, I will say app keys dot count value. So I am passing a parameter called count value, and the value is 125, and then I'll say dot build. So this will create kind of a map, a name value pair map, and then I can pass it as a parameter, as an input to my worker. Then I build my worker and then queue it. Go to the WorkManager, go to workmanager.getInstance.onQueue. So that's basically the idea. So constraints allow you to define some conditions that must be satisfied, such as network connectivity, device charging, device being idle, the availability of storage space. You can put constraints, and then when you create a work request, you can say to the work request, only run this work request after this condition is met. So when you in-queue this request, when you ask the work manager to run this request, the work manager will take your request, store it in its database, and then it keep waiting. It will wait until the opportunity comes where all these constraints are met, then it will go ahead and run your job. So you can see here, very, very powerful. It waits until this, in the future, hopefully these conditions will be met, and then your task will be executed. The other, even more powerful feature that Work Manager has, you can orchestrate and you can chain pieces of work. For example, do A and B, do A after B, sorry, do B after A, and do D after C, and do these two in parallel. And then once you do these two, go ahead and run E. You can do a sophisticated task like this. So here it is. So for example, here I have two parallel tasks, download request and filter request, two parallel tasks. What I can do, I go to Work Manager, I'll say begin with these two parallel tasks, run them in parallel. When they finish, go and compress, do the compression, and then go and do the upload, So on queue is basically schedule this to be run. Run these two in parallel. Once they finish, continue to compression. Once it's finished, continue to upload. So it's very powerful. You can chain requests. You can chain work pieces. It's kind of a workflow. You can run some in parallel, some sequential. So realistically, I'm still working on some realistic example I'll be posting shortly, but this is an example usage in real life. So you might have some image filter to basically take your images, compress them, and only do this compression when the storage is not low. And then when there is internet or when there is Wi-Fi, you go ahead and do the upload. So you can do, for example, these three tasks in parallel, and then you wait for them to finish, then you do the compression, you wait for it to finish, and then you upload. So instead of having a job or a worker that does so many tasks, you have smaller workers, and you can combine them together. And you can run some in parallel, run some sequential, and so on. And you can, of course, define constraints for each one. So the final thing you can also do with jobs, you can monitor them. So what you do, you go to your Work Manager and you say, get me a live data about how this particular job is going. Because when you create a work request, you get back an ID. And then you say, observe for me, observe this task, and whenever there is a change in the state, let me know. And when it finishes, read the results back. Read me the results back. So let me show you this. So what I have here is an example. Let me just put this comment this constraint. So here is my upload worker. Here's my upload worker. So the upload worker, as you can see here, it reads the input data coming from the requester. In here, it's reading the count value. It's reading the count value from input data that gets int. Then it does a loop and it keep uploading. In this case, I'm just doing a fake message that is displayed on the logcat. Then once this work is finished, I get the current date and time and return it to the caller. So I will return this date and time, and then basically I'll say everything went okay, and here is the result of my computation. For example, here output data, result.success, and I return this output data. Now, how do I observe this job and get back these results? How do I do so? So what I'll do here, let me just show you. Let me just comment this, just to keep it simple. So here is my task, which is called filter request. Yes, filter request, and no, not filter request. This is the one. This is the upload request. It is a one-time task, and I pass to it how many times do I want to do it, how many times do I want to do this, and I go ahead and build this request. Then I ask the work manager schedule this work request for me. So I'm sorry, I call this upload request. Say schedule this to be run later. Schedule this to be run, and then I go and observe it. So I'll go to upload request.id, and I observe this. I keep observing this particular task, and as it progresses, whenever there is a change in state, I get notified, and then I wait for the job to finish. When it's finished, I can retrieve back the output data that was produced by this upload worker, and I display those results in a toast. Okay, so let me just run this and try to explain it a little bit more. Yeah, so while it's running, let me just finalize this. By the way, these are the states a worker can go through. First, it is blocked, which means it's not running yet, maybe because the constraints are not satisfied yet. Then it gets scheduled to run. Then at a certain stage, it will start running. If everything goes okay, the state will be succeeded. If something goes wrong, the state will become failed, and the user can cancel, anytime can cancel this work. How do we cancel a work that we already submitted to the worker? So what we do is we simply go to workmanager.getInstance.cancel by ID, and we give it the ID of the work request, and this will go ahead and cancel that work. Another way to do it, I can add a tag to this work request, and I can cancel it by tag. So you can either cancel a work request by ID, or you can cancel it by tag. So a tag is just an arbitrary string that you associate with the work request, and you can use it to ask the work manager to cancel this request. So the final thing is you can also use coroutines. You can use coroutines inside your coworker. If you want to use coroutines, maybe you are accessing a web service, or accessing Firestore, or accessing, let's say, Room. All the API of Firestore or Room are coroutines. So if you want to access them from a worker, then you need to use you need to use coroutine worker instead of worker. So you saw here that if you are just if you are not using coroutines, you can just inherit from worker. If the implementation here will use some asynchronous tasks, such as talking to a room database or talking to a Firestore or talking to some asynchronous API. So instead of using worker, you will use coroutine worker. So this way you can make use of coroutines inside your do work. As you saw here, inside your do work first of all can be a suspend function, and you can also specify which dispatcher you want to use. Do you want to run this in the IO threads, or do you want to run it in the default thread? Which thread you want to run this? You can specify the thread to run your coroutines, your worker coroutines. So let's see if this one, okay, take a look at this. So I will be starting this work here, and I will be starting this work and then observe the results. So take a look. So I'll start it. It was very quick, succeeded, and basically here you get the time, date and time. Let me just put some, just to give it a try. I haven't tried it myself. This is the last thing, and I let you go. Let me just put some constraints here. Let me just comment this, and I'll keep it. I'll say only run this if there is internet. So let me run. So I run this, and I'll start it. Hopefully, when I start it, it should be okay. It succeeded and went ahead successfully. Let me see if I can disable the internet. Yes, air mode. Airplane mode. خلاص. Okay, here is an airplane mode. And now when I start this, it's on queued. See here? Why is it on queued? Because the constraint is not satisfied. This is the status. It's on queued. The constraint is not satisfied because there is no internet connection. Okay, so as soon as the constraint becomes satisfied, I enable the connection. See, run and successful. Any internet will do. Any connection will do. Let's now change this to unmetered, which means only when there is Wi-Fi. Let's run this. Let's start this. No, it's still running. So the status should be on queued, I hope. On queued, you see here on queued. And then because there is a connection, but it is no Wi-Fi. Unmetered means Wi-Fi. Connected means any connection, any type of connection. And metered means 3G or 4G or 5G. Now let me enable Wi-Fi. As soon as it's enabled, the work is it enabled? Yes. As soon as it's enabled, the WorkManager picked up this change, and the constraint is now met, and it goes ahead and run the job. So you can see it's a very simple API and very powerful library to allow you to schedule tasks for your app and to run such tasks even if the app is closed. Okay. So inshallah, that's it for today. I will